and welcome to Pass the Torque. I'm your host, Katie Cadre. You asked some really great questions this week, and we have Billy Gallagher here to give you some answers. Don't forget, we do have bubbles pop up to give you more information. Without further ado, I'll pass it on over to Billy.
Hi Katie, thanks for having me on today.
Please explain what you do.
I am a roboticist and a robotic systems engineer at NASA Goddard's Exploration and In-Space Services Projects Division. I work on developing the technology needed in order to send robotic vehicles into space to repair and refuel spacecraft, as well as manufacture and assemble new spacecraft in space. In addition, we look at ways that we can use that technology to explore beyond Earth's orbit and look at the moon, asteroids, comets, Mars, and beyond. And I also look at using augmented and virtual reality technology in an engineering and science setting and how we can use those kinds of new technologies to further develop NASA's capabilities.
What does human-robot cooperation entail?
One of the difficult things about robotics is making sure that robotics and people work together. And robotics and people work very differently. People are very good at picking up an object, understanding what it is, and feeling its shape and size, and being able to understand how hard they're pushing on it. But if you told a person that you have to place this object exactly here every single time, it's actually going to be a little bit difficult because people aren't that precise. Robots, on the other hand, are super precise. You can tell a robot, push here over and over again, and it will do it no matter what. But robots don't necessarily have the same intuition and feel for things that people do. So in putting together kinds of tasks that you're going to have people and robots working together, and this is especially true as we start to explore further out into space and we start to return to the moon and potentially send people beyond the moon, then you're going to need robotic companions for these astronauts that are going to go out there. And in order to make sure that the robots are safe around the people and the people are safe around the robots, we need to understand how those interact. In order to do that, we look at how people respond to what robots do. We look at how we can make it easier for people to control the robots. And we also look at what kinds of tasks are best done by a robot versus best done by a person.
What's the goal utilizing robotic technology in outer space?
One of the biggest challenges of working in space is the fact that it is space. It is cold, there is no air, it is expensive to get to, it's difficult to get people there. And in order to send people there, you have to send a lot of things with people. They need food, air, water, and space to live. One of the advantages is that robots don't really need most of these things. And so in the places that it's very difficult to get people to, we can send robots there to do the tasks that might otherwise not get done. One of those examples is refueling satellites in orbit. On the ground, you can just pull your car up into a gas station and put a gas pump in and refill it. In space, there aren't any gas stations. There is no tanker truck that's going to be able to come to you, and getting a person out to a scientific satellite in an orbit that is completely different than where we've ever sent people is actually very difficult to do. So that's a good example of where we can send a robot to be able to go and do those kinds of tasks, either autonomously or under the control of people here on the ground, so that we still have people involved in the decision-making and in accomplishing that task. We have the technology that we need now to be able to make a rover that can drive on the surface of a foreign planet. And the addition of the technology that we need to send people there is actually more a matter of time and cost as opposed to technological know-how. We know the systems that we need to build. We know how we can build those systems. It's just very difficult to get them there right now. So I actually think that we're probably fairly close to being able to build something that can get people to the surface of the moon, the surface of Mars, and have them actually establish a presence there and have a whole bunch of robotic companions that can run around and support those tasks.
What are some future goals of robotics in space compared to current robotics?
So the current robotic systems that we use in space have a very limited and defined role. There's the Space Shuttle robotic arm and the ISS robotic arm that are used primarily to aid in astronauts doing EVA-type tasks. So the Space Shuttle robotic arm was instrumental in things like servicing the Hubble Space Telescope, The ISS robotic arm is very helpful in helping astronauts get around the outside of the space station, as well as being able to reach parts of the space station that astronauts have a more difficult time getting to on the EVAs. It's actually it's very difficult to get those robotic arms to other locations because they rely on the infrastructure that exists at the International Space Station. So one of the things that we're working on trying to do is be able to build robotic platforms that can go farther away from a human presence. They can go to places like polar orbits. They can go to places like Lagrange points beyond the moon, orbits that we have never been able to get people to, and orbits that we might need the capability to do things, but we don't necessarily have a reason to send people there on a regular basis. Beyond that, then, we want to be able to get to robots that can help explore the solar system. We want robots on the moon that are going to help establish a colony. We want robots on the surface of Mars that are going to help explore the geology and the history of that planet. We want robots that are going to be able to go and explore the compositions of asteroids and comets and understand what they're made of, where they came from, and how we can protect Earth from them. The Space Shuttle Robotic Arm, also affectionately known as the Canadarm, was one of the first real robotic arms that we put into space. And it had a lot of new technologies for the time, and over the years, robotic technology has advanced. So the ISS robotic arm actually has newer components. It has a longer arm, and the ISS robotic arm has the ability that it can actually what they call walk off, where the robotic arm grabs here, and then it goes and grabs another spot with its other end, and it lets go with its base. And it can kind of inch its way along the ISS so that they can reach more places. The difference between those two arms and the OSAM servicing arm is actually its capability and its purpose. Those two arms were designed to be nice and long and be able to reach out and grab things in space and pull them in and be able to move stuff back and forth along the ISS. But they don't actually have a very precise movement, and they're actually not particularly strong arms. So for servicing purposes like the OSAM arm, where we want something on a much smaller scale, we can build an arm that's a lot more precise, and that gets us the ability to very carefully insert new components into satellites and very carefully thread onto fuel valves on satellites and be a lot more accurate than we can with big, long, spindly arms.
Could robots take over the exterior tasks on the ISS? And how difficult would it be to program them for such a task?
So robots already do a lot of the exterior tasks on the ISS. If it's something that needs fine motor skills, then the person's going to go out on an EVA and take out their tools and adjust the torque of fasteners and things like that. But if it's something that doesn't need that level of precision, the ISS robot actually does a lot of that already. One of those examples is searching for potential leaks on the outside of the ISS. We have a tool that is a leak locator tool that is on the ISS right now that they can put on the end of the robot arm, and the robot arm can go back and forth and sweep across the exterior of the ISS looking for any potential leaks. And this is a much more efficient and much easier way to find these things than having a person have to go out on an EVA and cover every inch of the exterior of the station. So that is actually one of the ways that we're already trying to use robotic arms to reduce the amount of manual work that needs to be done by an astronaut on the exterior of the spacecraft. As to how hard it is to program, it depends highly on the task. Something like a leak locator tool is actually fairly straightforward because all you're doing is giving it a bunch of back and forth motions, and the robot will eventually be able to cover the entire surface of the ISS. And an operator on the ground can sit there and monitor it while it does that. As you start to get into some of the more complicated tasks, like reaching out and grabbing a visiting vehicle that's bringing supplies to the ISS, those tasks require a little bit more monitoring from the operators on the ground and a little bit more careful planning so that we can make sure that we don't damage any vehicles when they arrive.
What has been your most proud moment in your career at NASA, and why?
So I will admit this is a difficult question. The mission that I'm working on right now is in the middle of working on all of our approvals to get our flight hardware. I can tell you that when that mission launches, that will be the easiest answer to this question. But up until this point, I think I can come up with a couple possible options. I have to say that when I first started at Goddard, I worked many years to be able to get a job at NASA, and I knew that I wanted to work on spacecraft because I find the concept of space travel fascinating, and the concept of exploring further out into our solar system, into the unknown, a fascinating way to understand who we are and where we came from as people. And so when I first started at Goddard, I had the opportunity to work on a project that sent me down to Kennedy Space Center. And we were building a robotic system that could be controlled remotely to test out some of the ways that we would refuel spacecraft. And while I was at Kennedy Space Center, I had worked for NASA for all of 3 months at the time. I took the opportunity to explore and go see the old Apollo 1 launch pads, the old Saturn V launch pad that is now the Space Shuttle launch pad, that is now the SpaceX Falcon launch pad, or will be the SLS launch pad, and really took the opportunity to kind of take in the sights and the scenery around me. And that was definitely a amazing experience to realize that I put in many years of work through college, through grad school, and all of that, and it all had actually paid off to get me here. I would have to say that the other proud moment, it was actually just a year and a half ago. I worked on a mission called the Robotic Refueling Mission, and that is an experimental platform that we send to the ISS to then use the ISS robot to test out a bunch of the technologies that we're building for doing satellite servicing and repair. So I got to go down for the launch of that. And that was the first time that I had ever watched a rocket launch in which I actually knew the hardware that was on that rocket, and I had built something that was on that rocket. And that was a very exciting opportunity.
How much fun are you having? Looks like a great job.
There is a certain excitement that involves walking into the integration and the testing buildings at any NASA facility. And the fact that I get to walk into those every day to do my job is just something that I try to never forget. I try never to forget the fact that I work in a place that builds once in a lifetime hardware and unique things that will go into space and potentially travel millions and millions of miles from Earth and discover things that nobody has ever discovered before. And that's just exciting. That makes me enjoy my job and makes me look forward to being able to contribute to that kind of discovery.
How special are space actuators?
One of the things that makes building robotics for space very difficult is that the environment that these robots are going to work in is very different than the environment that robots are going to work in on the ground. If you were to go to a factory that's building cars, for instance, they're going to have all kinds of robotic arms, and they're going to be picking up pieces and moving them around and putting them on cars and everything. And those robots have motors that were built to be used on Earth. Those motors might use gears and lubricants to make things work better. They might use different kinds of sensors so that they can track where the motor is going and be very precise. A lot of those things actually don't work in space the way they work on the ground. So for instance, those lubricants that go into motors are very often made with liquids and greases that when you put it in space will either freeze and solidify or will what we call outgas. It'll basically boil away into space and you'll have none of it left. So in order to build an actuator for space, which comprises of a motor and a gearbox and all the things that are needed to drive the robot, you need to come up with different kinds of lubricants. You need to come up with different materials to make the gears out of so that the hot and cold of space doesn't warp them. And that's another thing that isn't necessarily obvious about space. Most people think of space as cold and desolate, and there's nothing there, there's no warmth, there's no light, there's nothing. But really and truly, there's actually a lot of light because there's nothing to block the light. So the sun shining directly on something in space will make it very hot, even though there's nothing around to hold that heat. But gears don't like getting hot and cold and hot and cold and hot and cold. They crack and they'll change shape. So you have to make gears out of very sturdy materials. Also, some of the sensors that we use on the ground don't necessarily work in space. Like I said, the sun is actually very bright. A lot of the sensors that we use on the ground require being in dark places, and they go in little cases and attach it to the motor, and then they use lights inside those little cases to figure out where the robot motor is going. In space, because the sun is so bright, those cases can't necessarily always block out the light. And so sometimes the sensors don't work the same way. And so we need to use different kinds of sensors in order to be able to follow the motor and understand exactly where it's going. So all of those things combine to need to build very different types of actuators in order to drive robots in space.
What are the popular robot programming languages?
So a programming language is a way that you talk to a computer system. And so you can think of a programming language just like you think of a spoken language that people speak in different countries. If you go to France, you're not necessarily going to be able to communicate with somebody who does not speak English. But if you learn to speak French, then you can communicate with them. And computers work very much the same way. Every computer system has its own way of operating, its own way of thinking, as you could call it. And each of those different systems works slightly differently. Programming languages are the way that people have come up with to make sure that people can tell those systems what to do. So we use a large variety of different programming languages for the different tasks. And the reason for that is each language has its own use case and its own purpose. We do a lot of writing in C and C++. Those are very common languages that are used all over the world for all kinds of things. And they're very well supported. We know very much how they're going to work, and so they're very reliable languages. So a lot of the control methods for the robot arms themselves are written in those languages. We also use a whole bunch of lab equipment that is for testing and is for supporting the development of these robots, and those run languages like Python, those run languages like Java, and it really depends on the hardware and what the hardware supports, which one of those languages you're using there. And then we have a lot of tools that we use for analyzing the system, for making sure that the robot is going to be strong enough to do the task that it needs to do, that the robot is going to be okay in the hot and the cold environments as you orbit the Earth. Those systems tend to run things like MATLAB or run in finite element analysis languages that are used for understanding the details of a particular structure.
Do you recommend any NASA programs for high school students interested in robotics?
Many NASA centers do internships with high school students, and we routinely have high school students from the area come in and do internships through the school year with us. And it gives them an opportunity to work on more advanced hardware than they might be able to get in the lab at their high school. It gives them an opportunity to see the spaceflight hardware up front and to learn what kinds of things that it really takes to build a spacecraft. And so if you're interested in doing internships like that, you should go to NASA's website and go to the internship section, and there's going to be information on how you can apply to be a high school intern at your local NASA center. And then one of the things, once you get into college, NASA takes a lot of college interns. NASA also does co-op stints, which is basically a longer version of an internship, where you spend an entire semester working with a team at NASA. I actually did that. That's how I started at NASA. I did an internship several summers at NASA Goddard, where I work now. And then I also did a co-op period at JPL, where the Mars rovers out in California are built. And so that's another excellent way to really get involved and learn what goes on at NASA and get some great hands-on experience.
Please tell us about your hobbies outside of work.
So yes, my life is not all about building robots that are going to go into space. I also have things that I do for fun, too. And one of my favorite hobbies is actually flying. I have a private pilot's license, and I'm a member of a flying club here in the DC area, and we own our own plane. So it's a small 4-seater plane, not the size you're going to see at an airport, but basically about the size of your family sedan, but with wings. And I enjoy taking it out on trips on a weekend, maybe fly out to the eastern shore of Maryland. Flying over the Chesapeake is always very spectacular. Makes it easy to get out into western Maryland, out into Shenandoah, Virginia, go hiking. There's lots of good places out there for camping and sightseeing. And so that's one of my favorite things to do. I'm also into photography. I have a DSLR, which is a digital camera with interchangeable lenses, the kind of big camera that you'll see photographers using on the sides of sports games and things like that. And I love to take that camera with me whenever I go places and capture the beauty of nature. Say landscape photography, astrophotography, sunrises, sunsets, waterfalls. Those are my favorite things to take pictures of. And the two of those together naturally mean I like to travel a lot. I like to see the world. I like to get out and go places and learn about how other parts of the country, how other parts of the world live, and see fascinating sights that you're not going to necessarily see in your backyard.
Thanks so much, Billy. And thank you for another round of great questions. Don't forget to check back here next week to meet another one of our NASA engineers. We'll see you then.
I've got some fun stuff to share here too. I didn't mention this earlier, but I also love Legos. And so I've got a few exciting space Lego models to show. So we've got a lunar lander here, complete with, you can see inside the lunar lander. The astronauts must be out on a excursion right now because it's empty. There's also the space shuttle, all set and ready for takeoff. We've got Mars rover over here. This is Spirit and Opportunity. And then we've got a Saturn V rocket, bit taller than all the other things. And then we've got some fun little things down here. We've got an astronaut on his way to the launch pad. We've got a little diagram of Margaret Hamilton figuring out how to classify all the stars. And then over here we have Nancy Grace Roman, otherwise known as Mother Hubble. NASA actually just renamed a new space telescope after her.